So now let's go ahead and discuss a little on exploratory data analysis. So what does EDA mean? EDA actually represents us exploring the data without even getting ahead and starting with the model. So basically data encapsulates various information that isn't just represented in the form of a table. For example, this data that we have loaded in our notebook uh, has numbers, but can we actually infer directly anything from it? Maybe, maybe not. If you're an expert, maybe, but for normal people, it's not actually possible to just directly look at data like this and then make an assumption related to it. So what we do is we start exploring the data. It comprises of different techniques. For example, if we have numeric data, then we start by exploring the data as to what the data uh, actually has as attributes. For example, there are these various attributes, around 80 of them are there in our data frame. Other thing is that we start to analyze the data based on what it represents in terms of its known feature or its statistics, like its mean, its variance, and different kind of statistics that we can actually gather without even performing any task using a model. So yeah, numeric data have different method. All the kind of like categorical values have different different type of exploration to them. Then an ordinal value has a different kind of exploration, and all these things have a different method and different operation. A text value or a text data comprising of text has a completely different set of EDA operations that we can perform on them. Images have different kind of operations that we have to perform. So basically each kind of data, even though all these have numeric essence to them, we still have to perform different kind of operation related to that data. So yeah, what EDA actually helps us to achieve is that when we perform EDA, we get to know various aspects of different attributes or the complete data per se, or different fields. For example, if there's a particular row which has one particular column which has null value, then we might not actually want that in our model, going into our model, because maybe that particular feature or that particular column represents something very critical for our machine learning model, but it's not actually present. So yeah, these kind of operations, depending on the EDA, can be performed performed after all the operations that are related to that type of data are performed over it. So let's go ahead and try to see variations that different all these different we basically have touched a little on analyzing and cleaning of data, but we haven't much explored it. So for that, what I'll suggest you to do is you can go to my GitHub account. So yeah, you'll find this notebook on COVID-19 that was a very basic EDA project that I performed, and you can actually explore different operations and different methods that are used to explore data overall. So here what I've tried to do is first look at the data, visualizing how different areas across the world are affected due to COVID-19. It was done in actually done around end of March, so it's not brand new, but yeah, it's uploaded now. So yeah, it's there. You can see how much different areas of world are actually affected. So yeah, it was in the very beginning of April. So yeah, India is not that affected by now, but as we know now, it's quite affected. So after that, I have explored a little on the relation of different columns, how they are related, and their factors by which they are related, correlation and covariance of each each value or each attribute that represent the data. Then I've tried to analyze how the data represents situation in various countries, which countries are most affected. So mostly, for example, yeah, it's a good point actually, that we count the number of cases in a country as how bad that country is actually hit. So even if you go on Wikipedia, you'll see that countries are ranked according to the number of cases that the country has already seen. But what about the countries that have more fatalities than others? Maybe they need some particular kind of attention. And what about the countries in which the number of fatalities uh, the ratio of number of fatalities to the number of cases that appear there is more than others? So, did you even think about Gambia by now? Maybe you did think about Italy or Spain or China, of course, China, but did you think about Gambia, like Rangu or Cabo Verde, whatever, all these countries? Did you know that they are that bad affected that 33% of the cases there are actually dead? So, yeah, all these insights can be drawn from performing EDA over the data. So yeah, more of that you can go ahead and explore. I have actually tried to explain a simple mathematical model known as SIR model. So by which I have actually modeled this particular set of data and whatever, all these things. So yeah, go ahead and explore that and see if you can find other insights over that data. So getting back to it, what I was going to discuss was how all these rescaling and manipulation of data based on the EDA that we perform actually brings about some change in performance of the model. So nothing much here, just naming all the columns. Then we have loaded the data, and we have just for the sake of this model, we have just included the numerical values here, int values and float values in the data frame. So as you can see, all the all the values that were object, 43 of them actually are now not there. There are just numerical values in the data frame. So after that, we go ahead and split the data into our basically in our data that we are going to feed to the model and the data that we are actually going to predict. So you don't actually have to worry about what the split is and how all these operations are being performed. Just to give you an idea that what these actually bring about, the changes that they bring about in performance of model. So I executed this, I split the data, but this step is called as scaling of data, but I'm not going to scale the data for now, so I will skip this. So if I print data right now, there are 1460 rows and each row has 36 columns. So yeah, and the value in is of the shape 1460, means there are just 1460 rows and just one column, and maybe not even column, it's just a vector. So y is the result that we want to get, x is the input that we are going to give to the model. Now a very basic splitting of data is done to actually train the data first, and then we want to test if our model is actually trained good to perform different means predictions over different instances of data or not. So we split the data into training and testing. uh, After that, we build a very basic model using sklearn.linear models linear regression. What linear regression is, what all these operations are, you don't have to worry about them. All you have to see is how the various operations like scaling and shuffling the data actually help or improve the ability of model to learn. So yeah, just going ahead and executing this. So did I split? No. Yeah, so I split the data, then I perform the prediction on new data on the test data. After that, we get a mean squared error of this much. After that, let's see how much R2 score. R2 score is basically a metric by which we test the ability or wellness of our model. So right now it's at 62, 0.62. It's not a percentage from 0 to 1, but 0.62 is what we are getting. So just know relatively how the model is getting changed. So right now it's at 62%. Now, if I go ahead and scale the data, the shape remains still same. Scaling basically means that bringing all these different, what happens is that all these are of different scales, like temperature is on a Celsius scale or a Fahrenheit scale. And then there's another feature, for example, pressure. So pressure is on Pascal, so you can't actually see a correlation between temperature and Pascal or pressure. Maybe you can in terms of physics, but you can't actually relate them in terms of their scale. You can't say 50 degrees Celsius is less than 45 pascals or something like that or whatever. So yeah, that can't be done. So what we have to do is we have to bring all these columns or all these features to a unified scale. So that is what scaling basically represents, to bring all the attributes related to our data on a similar scale, so that we can actually start relating those data points. So yeah, I go ahead, I scale the data now, and I again split and check the shape. Now I still have my shuffle at false, so I'll go ahead and perform a prediction. Now let's check the R2 score. So not much, but it did help the model. 0.62, now it's 0.63. Now let's go ahead and perform another operation, and this time set this to true. Now again, going ahead, training the model. This time let's go ahead and see. So we went from 62 to 63 after we scaled the model. Then we shuffled the data, and we can see a great rise of about 20% or even more than 20%, 63 to 85. Not percent, but relatively this score is much higher than the score that we previously got out of the model. So yeah, this is a relatively better performing model. So now we know that performing different operations based on the EDA that we perform on the data, like manipulation and rescaling, and how we actually clean after analysis of the data, can actually affect the performance of our model. So yeah, this is the basic of EDA exploration and all these things. So you can explore more on that, and you can go ahead and take a look at how actually EDA is performed with different kind of data, and you can try out your own EDA on data that you download from the internet. So one more thing is that you might find that the environment that I'm working on right now has changed from previously. So previously I was working in the Jupyter Notebook, but now I'm working in Jupyter Lab because it's a little more flexible than that. It gives you a little more flexibility to work in. So yeah, why not?